So what we're focusing on this part three um, little session of ours that's going to take approximately a couple of hours to go over. We'll be reviewing some of the stair specifics, uh, particularly like we'll be reviewing the types of stairs, the attachment methods. I know that you'll see this frequently, maybe Synergy Preferred. Synergy Preferred is ambiguous in terms that we kind of have to suit what the client wants us to do. And every building is different, and every stair is going to be different, and every situation in terms of connections will be subject to, the design of the stair, the building structure, and the engineer, as well as the state that we're, what state or maybe country, depending if we do work outside of the U.S., what the engineering requirements are for connections. So when you see Synergy Preferred, really that kind of doesn't really apply to us. We have to be flexible enough to design something that works with this, the concept and design that we're given by the architect and the engineer. We'll also review quickly stringer buildups, um, treads and risers that we've often had to work with. And then we'll deviate a little bit off of the types of stairs and we'll dabble a little bit into the submittal and fabrication drawing processes. And specifically, we'll just be looking at um, updating for as-builts. So that's going to include field dimensions, whether it's point cloud or any other kind of field survey that's given. Sometimes just old-fashioned tape measure and a laser level, and we're handed a sketch and we go from there. So we'll just review that quickly in terms of how we try and incorporate those field surveys and any markups from clients and engineers into our final submittal drawings. And I think that will be the gist of what it is that we'll be reviewing today. Questions so far?
No.
All right. Silence is golden. Or you're all asleep.
That's why I shut my camera off.
Yeah, no, fair enough. Camera, I don't even have a camera. Fair enough. Let's see. So my understanding is it sounds like the two of you have had rather extensive experience in at least fabrication drawings for looks like miscellaneous metals and stairs, I assume.
Yes, we've actually gone through the list. I've personally been involved with 6 projects at our previous employer, building for Synergy. Most recently, the 4 stairs that were at the Hank project.
Right. Okay. Well, so you already got some knowledge in terms of the submittal drawings, fabrication drawings, and types of connections that we may be doing, and kind of like things that we look for. So I imagine that most of what I'm going to be reviewing today will not be new to you.
It'll be slightly new to me.
Slightly. All right. What's your experience?
Just whenever I've worked with Bill and under some of the stuff, basically doing the drawing aspect of the models that he provided.
Oh. Okay,
Yeah,
fair enough.
My role in that, Denny, was that we took and the company we worked for fabricated those stairs, and we would take your drawings, create models, especially for the H stairs where they were curved. We remodel those so that we can create shop drawings for the fabricators, where the drawings that we receive aren't flat developments for those. So we have to model that, turn it into sheet metal, and Tim's role was to take those parts now and turn them into actual shop drawings that the guys downstairs could fabricate from.
Okay, cool. So really more fabrication part for in-shop use. Sounds like, okay. Well,
yes,
that's cool. All right. Yeah, we Synergy, I mean, we have a bit of a shop in the back in terms of like the Elkridge office. I'm not exactly sure what our capacities are in terms of fabrication. We used to have a company previously was located in Montreal, Quebec, in Canada. So they would have a shop and they would also fabricate stairs. We bring in the raw material and start assembling things together. We did less structural stuff and more ornamental aspects of like the work. But similar, the drawings that we did were trying to tailored to suit specifically the fabrication drawing process. They were tailored to help the fabricators to create the parts needed and assemble it together for shipping to the job site. So yeah, again, I'm sure most of what I'm going to be talking about is things that you've already experienced and are aware of, but there might be some new things in there. We'll see as we go along. So I've just pulled up on my screen here. I'm assuming you can see it. This is just basically a breakdown of each item that we're going to be reviewing today. I'm not necessarily going to read it line by line. I'm going to be improving a lot of this. And if you want to, I can make this accessible to you later for your review if you feel that you might need a little refresher at some point, but I don't know if that'll be the case. Either way, though, I will send you the file if you need it. So let's
it's always good to have, something to fall back on regardless, you might not need it now or 2 weeks later, but you never know, like maybe 6 months to a year down the road or whenever,
No, agreed. It never hurts to at least have something that yeah, because there's so much that you'll be reviewing in your first couple of months here with the company that I'm sure you're not going to necessarily be able to remember everything. So if later on you do recall that, oh, I think this was mentioned, but I wasn't sure what was specifically discussed, and you at least have something to fall back on. So I wouldn't mind at some point cleaning this up a little bit and making it more of like a PowerPoint presentation thing, but that's I don't really have that kind of time right now to delve into that and start getting creative with graphics and whatnot. Someday maybe, probably after I retire.
It would be helpful. What Dan has done the 2 previous days is he's sent over emails of the material that he covered. So yeah, if you were to just email the file over, so we'd be able to have it on hand. That would be really helpful.
Great. Yeah. And I think in addition, with the videos that we're creating with today and tomorrow's training, you'll also have visual and audio, files that you can review to kind of freshen up everything that we've talked about. So let's see here. Stair types. I mean, okay. Types of stairs. And it's going to sound a little bit silly the way I'm talking. If there are specific terminologies to it, I don't really know them. It's not like I've received training like this myself. It's just I've been kind of thrown into the mess and been made to figure things out on my own. But I mean, stair types every stair is going to be a little different. We never really had a job where we could cut and paste a stair layout from a previous project into a new one, and just maybe change a couple of little things on the title block and call it a day. Every architect likes to do something creative when it comes to these, what I call a feature stair or an ornamental stair. They're designed to be sort of like a showcase to a room, usually an atrium or kind of like a main point of like a primary element in a room that's designed to draw some attention. And so architects like to really push the boundaries of what can be done and be creative with the materials, the designs, and sometimes it works really well. And sometimes due to engineering requirements, we have to make a few tweaks here and there. But the general shape of the stair doesn't usually change from what the architect envisions using. We may have, the architect may provide us with preliminary architectural drawings that shows stairs to be, it could be a straight stair running from one floor to the next, might have a landing, might have more, might have no landings if it's a short enough span between floors. We can have shapes that are L-shaped or U-shaped, and we also have spiral or curved stairs. There are all kinds of shapes and sizes we work with here. And if I've opened up my Explorer properly after it crashed on me, I can try and show you some samples. So let's try. So this one here would be a circular stair that spirals upwards 4 floors, starting from like the main floor going up. And this particular stair that we worked on, we didn't do the structure of it. We just provided the railings, but it's an interesting spiraled stair in that we had different radiuses as you started moving up. So, from the main floor going up to maybe halfway up the stair, you might have one radius, then transitions to another radius. So as it goes up, you can kind of see here how the stair gets bigger and kind of, twists around. It's not just one straight, simple spirally stair. So we've worked with stairs like this. We've worked with, curved stairs that are not necessarily fully circular, but just part of an arc. This one here is from Menlo Park. It was a shopping mall that was done back in, I'm going to say 2013, maybe. We've worked with, let's see, some circular stairs. Don't really see it too well in this one, but there was in Winnipeg, actually, Dan White worked on this one. I'm not sure if it was near where he lives, but it's in his province. And again, circular stair going up. Post Houston, I think, is something far more recent that we've worked on. You might have seen pictures of this more frequently online, and maybe some of the other material that might be forwarded to you, where it was a circular type of design. Straight stairs, spirally stairs. I mean, yeah, they're stairs. I don't know what more to say, really. We've had stairs that had a curved landing. So this is which job was this? JBG Smith headquarters. I have not worked on this. This was done by a contractor, but the company did fabricate and install the components. And you can see this is a switchback stair. So it goes up, there's a landing, returns back to this in the same direction from where it came up. And we had nice kind of like a circular landing. We don't have too many of those, but it does happen occasionally. And let's see. Let's try Pandora here. Was perhaps more of a U shape. There's not many pictures of this one, unfortunately. Small section going down from the floor. Then you got a longer straight run between two landings, and then it returns back on the lower floor. So this is maybe an exaggerated U shape. There has been other work that we've done where, let me see if I can pull up a, no, it's still loading. Well, okay, that's not going to work. I was hoping that would load. When things don't go according to plan. Just close the window and hope I don't break something. Can I do this? Maybe. Let's try that. Well, that doesn't really show the whole thing. Okay, never mind. So that plant went south. So yeah, types of stairs. I mean, what's there to say? I don't know what really to add to that. So we'll move on. Any questions on that so far? Or have you seen or experienced any types of stairs that you feel we should talk about, or have any questions on that so far?
No, the stairs seem pretty straight, like the types that is seemed pretty straightforward and basic shape, of course, creativity taken away from that, but yeah.
Right. Yeah, I mean, it's a stair. What's to say? We've occasionally worked on some ramps, and also on for Synergy, we'll also, where there's a stair, there's typically railings on a floor opening, so we'll work on some railings as well in addition to just stairs. Right, so we it's not just structural, but it's ornamental railings, and the creative part of a stair tends to be a little bit more around the railings, whether they use perforated panels or glass or any other type of system to create that guardrail. That's really where a lot of the differences can kind of like pop out at you when you compare one project to the other. But structurally, for the most part, stairs are fairly generic in terms of how they're built. That the shape may be just a little off from one project to the other. So we'll move along to stringer types. So a stair stringer is obviously is supported by one or more stringers, typically two stringers, one on either end of a tread and riser. I'm sure you're aware of that. We've had some projects where we've had stairs built with just a singular stringer, and I keep bringing this window up, but I really want to bring not that one. I was going to give you an example here, but again, my whole system's slowing down today. We've had situations where we have a singular stringer, say, in the center of the stair. And an example of that you could probably find on the website would be RTKL's. Is one of them? Maybe not. Not even sure if we have a picture of that yet on the system. We may have stringers on the very edges of the treads and riser plates. We may have stringers that are somewhat inset, sort of like this one here, where the treads and risers would extend beyond. We have, let's see, what other kinds of stringers? Do take your time. Susan, Leonard, Again, so this is what happens when my computer shuts down. Let's try again and see if I get lucky this time. Model, and I want. It's going to show you a sample of a stair that we've done where we've had a stringer centered. Bit of an unusual design. Okay, so that worked. Yay. You can kind of see on the underside, if I were to change this maybe more to conceptual. We had, so a center stringer. This one was actually cladded with plate all around, but yeah, stringers are not necessarily just always going to be on either ends of the treads and risers. And because of that, we may end up having to use different profiles to create the structural component. So some of these will be, let's see here, they can be made out of C-channels for your stringer types. Those are more commonly used at the very ends of the treads and risers. They're great in that they are a simple profile to work with. They provide some nice flat surfaces to attach a railing to, or to weld our treads and risers against. Channels don't really have an exaggerated rounded edge that can kind of complicate, or minimize the flat surfaces that we have to weld anything to or against. And architects nowadays are really keen on trying to get as sharp an edge as possible. So oftentimes an HSS is not desired, and we'll try and make something out of a C-channel, possibly with a welded plate to try and box it in a little. That would be more of a built-up stringer that I'll touch on briefly, but this would be an example of a model with a channel that's designed to be the structural component of a stringer. And the plate was more to allow us to attach our railings to, but I'll get into that in a little bit. So those would be the pros and cons. So again, we have a nice big flat surface on the channel. It's great for welding posts, flat bars, or anything else in terms of railings. And yeah, the downside to it would be that any connections, if it's a bolted connection for whatever reason between the tread and riser plates or any other element, maybe a splice joint that would require a splice plate. If it's bolted, you're going to end up seeing the bolt heads on the other side of the web that's exposed. And again, not generally something that architects like to see in an ornamental stair, but where there's a channel, typically that would be cladded or boxed in with some other kinds of a finish, whether it's a wood or stainless steel cladding, painted steel maybe. And that would allow us to hide any of those unsightly little bolt heads and nuts and washers, and maybe even weld bleed-throughs when you're welding a plate through a thin web. It kind of distorts the face a little. You can see that when it's painted. The other types of stringer that we often work with is the Otherwise, I keep changing. So the HSS, the more common one that we've worked with, real easy to use. I mean, it's usually rectangular in shape, or it could be square. They're abundantly found everywhere in terms of construction industry. So I mean, most fabricators are quite used to working with HSS tubing. The downside to it is, of course, the exaggerated rounded edges that, again, not all our architects are fond of seeing. And it does reduce the flat surfaces that we can weld any posts against or treads and riser plates against. But they are nice for sleeve connections when we're splicing stairs on site. We can't always ship a stair fully assembled and ship it to site. We sometimes have limitations where we can only crane so much up, or we have to use an access elevator. So if we split it into smaller pieces, an HSS is great for having those internal sleeves that allow people to fit the two assemblies together, do their complete joint, you know, the CJP welds all around, and then call it a day. So that it gives a clean, it's a cleaner assembly system, but again, in terms of the actual final look, not always something that the architects desire. So I'd say HSS tubing is probably more than half of the type of work that we do with in terms of structural stair design right now. So those are the two main components that you'll often see in projects. The other ones are if we custom fabricate a tube or a stringer, there may be several reasons for that. And some of that may be they want an integrated pocket for their glass system, maybe. This would be sort of like an example of a built-up stringer. The whole component is basically one large plate. Let me change this back to conceptual here. So we had, I'll remove the cladding. No, okay, well, I'm not going to remove the cladding. So we have a large plate, I believe was 1/2 inch thick with a channel welded against it. And we had a flat bar and then another plate. This one would be stainless steel, and this would create a pocket on the inside that we could slide a glass panel in to create, you know, to install our glass railing. So we didn't need a separate shoe. It was built into the system. So this whole assembly here came on the site as one big component. And it was it's a series of built up parts, whether they're, you know, a combination of HSS tubing with plates or channels with plates. Sometimes the built up stringers are just made straight up from 4 different plates welded together, create a box. We may do that if we can't find a stock or a typical shape HSS profile, and the engineer is specific on we need a certain thickness of vertical plate, or maybe there's some other things to consider in the design overall. So we may come into that situation where we're actually building everything out from 4 plates and welding it together. That gets a little bit more expensive whenever we build up a stringer. You know, it's a lot more welding, a lot more part drawings that we have to create. So a little bit more expensive. It's not frequently seen, but it does happen. And the last one that I want to touch base on was just using straight up plates. What's this one here? Other strange shapes. Custom fabricated tube made of plates. Right. So I talked about that. And the other one would be plates. I didn't list that here, but where we would have a really thick, maybe 2-inch thick plate. We could find that somewhere by whatever, 10, 12 inches. And I thought I had a sample of that somewhere I can kind of show you. JBQ is an example of that where it's actually a pair of plates side by side, and we had some fittings that would kind of slip right in there. You can kind of see a little bit in the picture here where you've got this gap in between the 2 plates, and you can also see it here through the glass flooring. So we don't typically, I mean, except maybe with the exception of an HSS tubing, generally the profile is something that the architect will kind of specify for us. They may have a very specific need for why they want a profile used. If the engineering that we do on the stair says that we can't use that profile, it's no good, then we may kind of propose an alternative. but ultimately, I'd say most of our projects, the stringer type is chosen for us, and we go with whatever it is that the architect and their engineer decided that was needed for their project requirement. Any questions on that for stringer types?
Nope.
Okay. They're they're usually steel. Fabricated stringers may be made of stainless, but most of these stringer types are going to be just some form of mild steel or steel and then painted or cladded after the fact. So that kind of covers that base here. Let's see. Moving on. Treads and risers. Okay, a little bit more to talk about in this one. So again, going back to what I said earlier with regards to stairs being a sort of like a showcase for architects in a certain room, they like to get creative with their treads and risers, and they can come in different kinds of shapes and finishes depending on how well it fits in with the design of the rest of the building. We're going to talk about the structural component of this treads and risers, so the main steel portion or sometimes stainless, and then we'll talk a little bit about the cladding or the finishes that can be applied on top. The more common, well, if you've worked in structural steel or miscellaneous metals, you probably are familiar with like the pan design of a tread and riser where there's a lip that's created at the nosing and they just pour wet concrete in there.
Yes, we've done that for you guys.
Yeah. So that's not something that we do frequently. I'm surprised that we've done it at all, but it's usually more in line with stairs that would be used in an emergency egress in an enclosed stairwell kind of thing next to an elevator. Um, More of that industrial look. So not something that we've done too frequently. I would say that what you've worked on would probably be maybe a rarer case of the types of treads that we work and do and fabricate.
Mm-hmm.
We will often work with what's called we form our steel treads and risers out of one shape with a panel, typically a plate that we bend to our will. And I can kind of show you an example here, maybe if I can do this right. It worked. Oh, that's a first. So for this job here, JPMC that I'm working on, we have a steel formed plate that creates both our treads and our riser. And this is probably going to be one of the more common types of designs that we utilize or that architects will want to use, that allows a flat surface on both the treads and the risers to apply a specific finish, whether it's wood or maybe a precast panel or something else. I don't think we've done carpeting. I don't think we'll ever touch that. Maybe tiles, but again, I don't think we've ever dealt with that. So precast and wood is generally the two main ones that two main finishes that we apply. The advantages of that is that we can create one part and just copy it multiple times, as many steps as we need. They're welded straight to the stringer, or the stringer may need to be sort of like what's called a sawtooth cut. So this is where we notch the stringer so that the treads and risers sit on the cut edge. They sit on top. And so having a form plate kind of allows us to also like extend beyond the stringer if we need it with that saw cut in the stringer. The other types that we may work with is where we have perhaps just a solid plate at the treads and no risers. So it would be an example of an open riser, if you will. Not something that we do too often, but I do believe I have a picture of that somewhere. See if where was it? Menlo Park. You see a little bit here on Menlo Park. We didn't draw this, but it kind of gives you an idea of an open riser. This is probably a bad example to show. This would have been made with a folded plate, but the one that I specifically wanted to show, which I can never find when I want it. Oh, is that what crashed on me? That's probably what crashed on me. Oh, wait, maybe not. I'll show you a mock-up. You might not see it too clearly here. This is for the Burbank project. Essentially, it was just a bent plate that gave you a flat surface for a precast tread with a slight rise in the back end just to give it some strength so that it wouldn't bow down with the weight. You might have this slight return in the back, or you might have it in the back and the front, depending on the visual look that the client wanted. The riser that you're seeing here is a perforated panel stainless steel that was welded separately from the tread. So this panel would be bent with a slight overlap on top of the tread, and then just kind of like stitched well to hold it in place. So the main structural component here was this, I believe it was 3/8 or maybe, yeah, probably around 3/8 thick plate. It was just bent, and that's what allowed us to apply this precast terrazzo on top. Let's see. So we talked about the formed, with or without riser plates. Form, pan, treads, and risers. So this is, yeah, we talked about this early on. This is more industrial and not something we typically do, where it's formed specifically for pouring concrete in. Yeah, the two main treads and risers, we kind of talked about that. We're going to jump to the finishes that we might apply. Actually, let's just go quickly back to the risers. So we talked about, or I showed you this picture here where we're seeing this perforated panel on the riser.
Mhm.
We don't often see that, just mainly because, you know, if you wear skirts, I'm not going to assume your gender, but if you like to wear skirts, or you know people that wear skirts going up a stair where someone from lower down can kind of look up and through that, it's probably not encouraged. So they'll usually, most stairs that we work in, the openings could be really minimal so that it kind of makes it less
Obstructs the view.
Yeah. Yeah. So we will often work with perforated panels. Usually it's a solid panel of some sort, or it could just be the wood, a wood finish that's applied to it. We've occasionally worked with some glass panels in the risers, and those tended to be would have a film applied to it. Whether it's it could also be like an acid etched or like a bead blasted kind of look,
Yep.
just to make that glass cloudy, and therefore you can't really see through it. And so JBG would be, well, that's not convenient. This one here would be a prime example, right, of the cloudy glass where you wouldn't really be able to see anything looking up. I still wouldn't be. I mean, I don't have a problem with it, but I'm not sure how how the ladies feel generally walking up and down these stairs. So the finishes for the treads and risers are the two main types that we deal with is precast terrazzo, where we'll show up on site with these panels of terrazzo or concrete shapes already made, and we just sit it on top of our stair treads with a grout, if you will. Or it could be bonded with some other form of adhesive, depending on the materials used. That'll be specified in part by the architect and in part also by our supplier. They'll probably recommend, depending on the product that we want, what's the best method of adhering that to our treads. So there's a precast terrazzo, which, going back to one of those pictures that I showed you, you could clearly see. So that would be a great example there of a precast terrazzo tread. Same with the landings. Precast terrazzo, something to consider is you can't exactly make that fit the full width of the stair. You do need to allow for a little bit of, not necessarily expansion and contraction, but more tolerances for the fabrication, since it is a poured substance. When they do their formwork, as they pour it, it's possible the formwork might distort a little. And also as it dries, it could also alter slightly the shape of the terrazzo, particularly on like some larger pieces. So it's generally recommended if we do terrazzo treads that they have a 1/4 inch gap between the stringer and the terrazzo. And this would apply to any other surface that it would be in contact with. So in this case here, where we have our precast up against the riser, we actually, you might not see it too well in these pictures because they're made with like a potato that acts as a camera. But there's a bit of a gap there between, I guess, the riser panel and the precast. So wherever precast would touch something else, we try and leave, you know, an eighth to a quarter of an inch gap there for those fabrication tolerances. The other thing to consider as well with precast terrazzo is the likelihood, and apparently this is something of a common theme that we've experienced on some of our jobs, is that if you were to look end to end on a poured terrazzo part or even a larger panel, it's not uncommon to see them twist. You know, one end it might be flush, and at the other end it'll be twisting slightly upwards. I don't know if it's a curing process, but there's something going on where it's not always going to dry flat. Maybe there's some reinforcing in there that has some tension for whatever reason, and it just like, kind of like wood, you know, as it dries, it curls a little. So it's something that we've noticed. We can't really control it, but you know, it's good to know, just so it doesn't catch you by surprise if you ever hear about that situation. It's not something that's related to our drafting. It's just, it's a fabrication process. Terrazzos will also generally come with a nosing strip. It's not just terrazzo, wood as well, but in this case here in this picture, you see that nosing strip that's applied. That's to prevent any slipping beyond the nosing, so that people don't, you know, fall and hurt themselves. Nobody wants that. That could be oftentimes a stainless steel bar that's just inlaid in the terrazzo. And some other times it's just a strip of, call it I wouldn't quite say sandpaper, but it's like a rough textured material that's just adhered on top of the terrazzo.
Yep.
And that works too. But I would say the majority of the time we're going to end up working with, it's going to be some kind of a stainless steel inlaid strip. As for wood, wood can come in a couple of shapes depending on the project requirement. I'm going to try and pull up this other job here that I had a model. Every icon is the same color of blue on my screen. So, you know, unfortunately, this isn't rendered for you to see, but we have a situation where we have a finished wood top tread. And again, you can kind of see the inlay strips here that we have near the nosing. But the top wood tread, if we ever do use or work with wood finishes, will, I would say, pretty much always come with some form of plywood or other kind of subflooring applied directly to our treads. That way there, the finishes and the treads, you know, it allows for, I guess it's easier to attach one onto the other. In this case, if it's finished with treads, probably any adhesive that they're using, or a combination of adhesive and maybe some hidden nails here and there, you know, works better with a plywood, bonds better to it than it would if it was straight up steel. And so the plywood would often be fastened. Do I have that in this model? No, not this one. Maybe this one. You can kind of see here where they wanted to bolt. Well, okay, we use excessive live bolts in this one, but smaller wood screws or others would be used to attach the plywood backer to our tread and riser plates. And that provided a nice wood finish for them to bond their finished stair materials to. Another example of wood treads would be a solid wood buildup. And we've done that with a project called Pandora, and I'm sure there's been other jobs as well. I can't think of any other particularly right now. Oh, maybe RTKL. And I'm trying to pull up an image, but I never can. So let's try going to my trusty folder. And solid wood. No, yeah, also no pictures on that one, unfortunately. But we had a situation where for this Pandora job in Baltimore, actually, so not too far from the Elk Ridge office, we had a solid built-up wood tread, and that was attached mainly just with these little steel tabs that extended, you know, about a couple of inches from the stringer. So we have this little threaded stud, and then the solid wood tread would be notched so that it lines up with these little tabs, and it just fits snug right in there. A little bit of adhesive and like some holes for our threaded stud. Yeah, threads, same thing. And I would bond the solid wood tread to the stair. So we've had this or variations of the system as well, but the two main ones would be the precast terrazzo and the built up wooden riser treads that we talked about here. Those are the two main finishes that we often work with. It's a little uncommon to have exposed steel, maybe on the riser, but not in the treads. It tends to be more of a slippery material. If we use something like painted steel, which I don't think we have, but if we ever do, it would typically have some kind of a grit, like a sand applied to it, or silicone, like silicone beads or something that would give it a rough texture to the finish. And again, prevent people from slipping on it should there be any water or, anything that would make the stair otherwise slippery. So a painted finish is not really something that we work with very often for tread finishes. Any questions on that so far?
No.
No. Going along quite smoothly. It's good. What's a concern design team we can exceed? There's an building strip. Okay. So when we're designing treads and risers, and I'll talk with this more in detail tomorrow, it deals more with like building code issues, but treads and risers, typical tread width is generally 11 inches minimum, measured nosing to nosing when you're looking at plan, and the riser height is maximum 7 inches. We'll talk a little bit more about like the actual design of treads and risers tomorrow, like what the minimum and maximums are and what numbers are we comfortable working with. Well, maybe this note here, I'll maybe remove that from this. We'll see. We'll see how I feel. Let's see what else is it. Connection types, spice joints. Okay, so let's talk about connection types for stair structures. Again, that kind of varies on a project. So connection types often refers to how we attach the stair stringer to the building structure at the top and the bottom of the stair. We're going to be considering, and that's something that, again, the architect and their engineer or our engineer will usually advise us ahead of time that depending on what state, East Coast or West Coast, if they're prone to earthquakes, we have to build in some slide tolerances, some tolerances for movement of the stair. And so we'll have some slip connections, usually frankly, it's a mix these days. Top or bottom of the stair, there'll be a slip connection, one of those ends, and the other one would typically be a fixed connection. How we attach the stair, again, depending on the building structure. If the floor is nothing but solid concrete, obviously we'll be anchoring into concrete. If there's a steel beam, say underneath a floor, that might allow us to tie our stair into that steel beam at the top of the flight of stairs. And at the bottom of the stair, if we're landing on a flat floor with no openings, then we just the stringer sits on top of the slab with a base plate. If it's part of several, like a set of stairs that's several openings, we'll have the stair obviously tie into generally the side of either the concrete opening or some kind of structural member just underneath the slab, and that repeats itself way down. And the types of connections, again, varies job to job. So some people may mention something about synergy standard. What standard? Every design is kind of different. So really, we work to the architects and the engineers' structural design for the building, the base building itself. And we come up with intuitive ways to attach our stair to it, hopefully in a way that it will not cause collapse. So let's talk quickly about stairs sitting on top of floor. And this is where I'm having real hard times with some of these models not opening up. But actually, maybe I might have spoken too soon. Let's do a Let's do a quick sample of this one here where you might see it. Come on. Nope. I just did something. I did a thing. Oh, last. Come on. Why are you not? Why are you doing this to me? It's not what I want. There we go. All I wanted to say was base plates. It's giving me all this problem. Is there anything here that I can kind of section through it? So an example of a base plate here, I'm kind of cutting through the stringer, so you're not really maybe seeing it all that well. Let's see if I can change that to an X-ray. We have like portion of a plate section here where we may, when we're attaching the stair at the bottom of the floor, if there's no openings in the floor, we can sit either on top of the concrete slab, or if the slab's not quite designed to hold the weight, we may request, or the architect may anticipate the need that we have to have a cutout in the floor slab, and we can extend our stringers through the opening and have it supported by structural beams below the floor. Either way, either system requires use of a base plate, and I'm sure you know this. And the base plate here, you can kind of see it where it's got slotted holes, which would allow for some movement side to side, or actually front to back. These slotted holes are a little oversized here because this project was on the West Coast, and with the earthquake and seismic activity going on the West Coast, it's the requirements for that slip connection is greater than anything you would see on the East Coast. So East Coast, you probably would rarely, if ever, see slotted holes or slotted holes drawn at this extent in any of the base plates or even the plates at the top. But base plates are typically will be bolted to, again, either the structural steel beam below or the concrete slab. We have instances where, if we're really lucky, we'll have embed plates already in the concrete slab, and we could just weld the stringer straight to those embed plates. Sometimes we're asked, and it's happened on a couple of occasions, where we have jobs where we are required to provide those embed plates in the slab. And so we may be kind of rushed to do a quick layout drawing and a quick fabrication drawing of those plates, where they should be located, so that they can install that in their formwork before they pour the concrete. And that kind of work is often done before we even have a chance to actually do the submittal drawings of the stairs. So we're it might be a situation of where we have the cart in front of the horse. You know, we haven't finalized the design of the stair, but we've already kind of anticipated where we want the embed plates and hope that we can design our stringers to meet with that embed plate. There'll be situations where the embed plates might not be installed in the right spot, and so some kind of a combination of welding it to where it does sit on top of the embed plates, welding that, and then maybe enlarging the base plate so that we can have a bolted connection in some other location. That could be another option. Those will be worked out with the engineer. It's rarely going to be passed on to you to try and make something work. You'll have some kind of guidance there, gets from the engineer in terms of how they want that connection to be done. And all you have to do is replicate that in your model and your drawings, and you're good. The other connection that we may have with stringers at the floor, and I don't have a picture of that, I think. Do I? I do not, but it would be something along the lines of angle clips on either side. Would I have it on this? No, I would not have it on this one. We would have clip angles on either side of the stringers. They're these long angles. Actually, hang on. I would have probably PDF file of that somewhere here. Maybe. Just give me a quick second here while I try and pull up this drawing for you guys. can kind of see it here. This unfortunately is the drawing I'm trying to open up in my model, but I can't. It's acting weird. So you're not really seeing it at all that clearly, but there's these clip angles right there. And those would be on either side. And here's sort of like a section through it. So you can kind of see the angles on either side. It could be on one side, it could be on both sides. The architect will have final say on that. And in this case here, here's an example of an embed plate. So we were able to weld these clip angles to the embed plate to secure the stair structure in place. Without the embed plates, we'd probably be using anchor bolts going straight through. They could be wedged, they could be an epoxy anchor, they could be screw anchors. Again, the engineer will typically state what they want to see used, and then you just replicate that in your drawings. If we use any kind of anchors consideration when you're doing your drawings, especially your fabrication and your assembly drawings, the first treads that you might have on your stair would probably, well, by probably I mean definitely get in the way of being able to have easy access to get at the angle clips or base plate, and either drill holes through the concrete for your anchors, or to weld, or to bolt your anchor bolts in there, with your tooling and everything else. So a lot of the times we're going to ask that the first tread and riser plate, if it's just one component, that would be shipped kind of like separate. And that would open up the area for our installers to have easy access to these clip angles or base plates and be able to put in the bolts or do the welding without, kind of having to crawl in tight little spaces and curse our names as they work. And then they'll just come back after the fact and they'll just tack on and re-weld the treads and riser plates back in position for that one section as needed. That might also apply at the top connections depending on how much room there is to work with. So those would be the two main connections if we consider a stair on top of the slab. Otherwise, top and bottom, we're going to tie into existing structure. It could be, if the slab is a solid poured slab with maybe a concrete beam just underneath it, that gives us a nice big flat surface. We can use that and tie our stair structure directly to the concrete with a nice big plate and lots of anchor bolts. Sometimes we have the steel we can weld to it. And sometimes we have to kind of cut around things and get a little bit more creative with how we tie to the structure. So I'm going to see if I can pull up a couple of examples here. That's just one page, unfortunately. That's just a step. Nothing here. Nope. Yep, maybe. This is what I want to show. Just want to show you a couple of examples here of some systems that we've used to tie. This is, it's the item 2 drawings, that's why. Okay. Let's fall back to the model then. Let's see what that does. Objects. Let's undo this. And then let's do that. And I wonder if I can. Okay, that's kind of working. Kind of. Maybe in this angle. I use a special parts in advanced steel, so it's not working too greatly for me right now. But essentially, we would have our stringer, in this case, at the top connection. Wow, really struggling here. Right, objects. Okay. Okay. Well, that's not at all giving me the desired result that I wanted. I'm just doing great with this training, aren't I? The computer's a potato, so it's not really fast either. Let's try this one here. What I was trying to show is, oh, that's why. Okay. So we would have our built up, or not built up stringer, but we'd have a stringer, whether it's HSS, channel, or any other. We'd have it return to the face of the opening. And in this case, the slab depth wasn't thick enough that we could provide an attachment plate. we have to consider that there's a tread plate here, and so our height was a lot less than what we would have needed. Plus, there could be issues with rebar, or if it's post-tension concrete, they really don't want us kind of drilling and cutting and messing around with those, and that can have an impact in our ability to anchor to the concrete. So for this particular example that I'm showing you, we were able to tie into an I-beam below. And to do so, we had to kind of build out our stringer so that we had a separate section of channel for this example. And let me see if I can do that without, no, it's still doing it. Ah, come on. Why? Oh, man, when things just don't want to work with me. There we go. We had a separate channel built up and welded to the actual stair just to give it a little extra depth, and that would allow us to kind of notch that built up section so that it could reach into and tie into the steel beam. We would have some plates coming along, and we could just weld to that, or not weld, but we can bolt through those plates. And naturally, it's not showing up here at all. Oh, there is. You can't really see it. Can I just delete this? Can I just delete that? Yeah. Okay. Well, in my defense, I'm still fairly new with advanced steel, so it's not quite as intuitively and easy for me to just kind of show you what it is I'm trying to show you. But we would connect to the steel beams in this case. We'd have either plates or modify a stringer in some way to fit around, clear the flanges and the webs. And we would bolt or weld on site to the beam, or it could be an HSS member that's under the floor. And that would be one connection type. The other connection type would be similar to what was at the bottom of the stair that I showed you in a previous example, where you'd have a connection plate that would span oftentimes it would span between the two stringers, and with multiple anchors patterned across. It might look something a little similar to this, but sort of like on the inside part with your anchors going into your concrete. And again, those only work if we're not messing around too much with rebar or especially post-tension concrete floor slabs. The engineers kind of, I wouldn't say panic, but look at it as kind of funny if we make that proposal that, yeah, we'll just anchor in PT slab, and if there's a post-tension rod in the way, we'll just cut it.
Oh.
We don't do that. We avoid that. We don't want to give them heart attacks. See, was there another connection type that I need to talk about? I think those are the two big ones. So stair sitting on top, mounted side, face, or floor slab. So that's what we just looked at. Mounted to steel structure under floor slab. Right. Okay. So we looked at that one. This is where it's mounted to concrete. Do I have an example I can show you of something mounted to concrete?
Hey, Denny.
Yes, sir.
What would you be okay with taking maybe like a 5-minute?
Sure. Yeah.
Yeah.
We can pause it and
maybe even less.
Resume at I don't know, 2:15 kind of thing.
That would work. I do not know how to pause the recording, so it might have to be two separate ones. I'm not certain.
That's probably the case, I think. I can't do anything on my end.
Yeah,
or just leave it recorded, and they can always edit out the part.
Okay.
That they don't want to keep.
All right, that works. All right, so returning by 2:15.
Sure.
All right.
downloaded all the pictures that Adam sent to me. Send those back to the boys. Specialty.
Are we all back?
I think so.
You good to go, Tim?
God, I had my mic muted.
Okay, no problem.
Yeah.
All right. All right. Well, let's resume this. I don't think we have that much longer to talk about things, so yay for you guys. Let's see here. While we were taking this brief break, I was pulling up some samples of some of the connections I was talking about in model and in drawings, just to maybe further clarify some of the connections that I was talking about. So we had situations where on our stair, and I just need to find the section plane for it again. That's always going to be the issue, isn't it? Yeah, that works. So we talked briefly about how at the bottom of the stair we may have these clip angles that could sit on a slab or steel embed plate. These systems can also be used to attach to structure at the top of a stair. And just to kind of show you a little bit here, this is a project called Burbank where we tie to concrete slab. And on either side of our stair stringer, we had these little clip angles on either side of our channel. And those would be welded to a steel embed plate, actually. We had this one solid formed. You're not seeing it on this drawing or the model, but it's there somewhere. If I could, no, okay. Well, we had continuous steel embed plate, and so we were able to field weld these clip angles at the top of the stair connections. And also we could do the same thing for the next flight of stairs going up to the next level, because they were tying into the side of the cutout opening in the slab. So that kind of illustrates a little bit how one system can be used. The other one, which I don't have a model of, but I have to pull up my old trusty PDF thing here. And, well, now I say that. There we are. Okay. The other one was at a top connection of the stair. We actually had a big surface of concrete that we could tie into. This is the Nova project, which is, I think, in the area of Washington. Not too sure which one it was there. Again, not too far off the Elkridge office, probably maybe a half-hour drive or something like that. And we were able to utilize a big base plate or a big plate attachment that was pre-welded to the stair stringer, and then we just went in there with a lot of anchors to bolt into the concrete slab. And so your plates ended up looking something like that for each stringer. And you can just see the quantity of anchors that we had in there for this particular condition. The size of the plate, the quantity of anchors, the spacings were all determined by an engineer. They were able to come back to us and say, yeah, you need all these. You needed little stiffener plates, just prevent any twisting and torsion effects of the stringer against that plate, give it that little extra reinforcing. And so this was a fairly big buildup that we don't often see in our projects. I'm not exactly sure what the requirement is on this one, probably because it was a fairly large unsupported stair. It was only supported at the bottom and at the very top. So all the rest of the weight was unsupported anywhere else. So I guess with that size of a stair, a beefier connection was required at the top. And at the bottom, we did a base plate, but we were able to through bolt to the underside of the floor slab and have access to the anchor rods, and just put in a plate washer and a nut, tighten it up. And that leads me to this other project that I'm currently modeling right now, JPMC, where we had something similar, although that's just recently been changed from a design meeting we had this morning. But again, the initial idea was to have a base plate, and then we could through bolt the concrete and decking, and then provide a big, a large oversized plate on the underside that would ideally, and the decking here isn't exactly modeled per the structural drawings, but the idea would be that the plate would span at least a couple of these open areas of the decking so that it's properly supported, and then your through bolts would extend through, and then we can get at that with a nut and a plate washer. If we had questions or issues about possible rebar in a slab, we could oversize the holes in the slab and also in the base plate, and then these plate washers would be a tight fit hole with a bolt, and wherever the washer and the bolt ended up being, to clear any members in the slab, we would just come around after the fact and weld the plate washer to the base plate, right, and secure everything together that way. So that's something that you might see and experience. And again, it's project to project, it varies. It's really up to the architect, the engineer, and what's on site. If it's existing, we have to modify our system to fit the existing structure. If it's a new build and we're there early enough, we may have some influence in how the floor should be designed, or if it requires an embed plate. Otherwise, we have to work with what's anticipated to be there and make some allowances for any field adjustments on site. And if you have any questions about what you anticipate needing, you always feel free to talk to your project manager. They're usually really good at letting you know how they think that it should be proceeded, or like how the design should be made if they have some concerns about anything that could be on site that you might not know of. Or if they're not sure themselves, they'll just forward the question on to a higher authority, an engineer or the project architect or a general contractor. Someone should have an answer somewhere, and they'll get back to you on that. So those were quick touch up there on the connections to top and bottom of the stair to the structure. And so the second last thing was going to be splice joints. So I talked on that briefly. Our stairs, depending on the design of the stair and the building and the access that we have to the building, we may be needed to ship our stairs in smaller sections. If it's a situation where we have access to a crane and there's no roof, or there's no additional floors above where we need to install our stair that we get in the way, then it's very likely that we would be able to ship our stair as a complete build and then lift it up and then drop it in place. And all they have to do for installation is just do the bottom and top connections and, call it a day. But we don't always have that luxury. Sometimes we have to use a service elevator or an elevator that's designated just for construction staff. We may have a crane, but there could be limited openings in either the roof, or that we have to kind of pull the structure through the window on the building and then kind of wheel it to the site. We've done that for a couple of jobs. Well, probably more than a couple. So in those situations, we're going to have to kind of break apart our stairs into 2 or 3 or even more smaller components based on the size that we can, let's say, how can I say this? The access area that we have to bring our stair in will determine the size, like the maximum size of our assembled component that we can fabricate. If we need to if we need to lift something through a service elevator, if the elevator is only 10 by 10 feet, we can't design a stair section that's longer or bigger than 10 feet. Obviously, it's not going to work. We can't do that. Also, a weight could be another factor to consider if we do have to lift it up by elevator, or if we're using a boom or I don't think a crane's really an issue, but There could be some weight restrictions that we have to follow. So again, a larger stair might be too heavy to lift, and we have to make it smaller components, and we have to size those components so that it falls within the weight constraints that we need to respect for, for shipping, for carrying it through this job site, and then having it put, it be placed in the position that we need for that to be stored temporarily until the erectors show up on site, and then, lift everything in place. Those are usually communicated to you at the start of a project. If there's any requirements like that for whether it's the size of an elevator or, if they have easy access of a crane and we can pre-build this in one shot, they'll generally let you know. But in the case where we do fabricate in 2 or more parts, we're going to end up with the need for having a splice joint somewhere in our stair. It's unavoidable. Splice joint can be for 2 main fabrication assembly types. It could be for bolted connections only, or it could be used for like as a backer plate for a CJP weld. So if you're seeing splice plates, it's generally going to be either bolted or welded. Frankly, I don't think there's any other way of doing it. We don't use Velcro. Tape is not recommended. So yeah, welds and bolts.
Really?
Maybe. I haven't tried it. You're free to try it down in the States. I'm pretty sure I'll never use that stair, so I don't mind. Others may complain, but that's not a me problem. That's a them problem. The splice plates that we use, we've had a situation come up recently where we had a weld inspector go on a job site for, I think it was a project called Cloudflare. And they inspected the splice plate that we had in the weld, and they didn't approve the weld that was used. And the reason for it was that the splice plate that we had designed, which is what we had typically done, was made of 4 plates. We had, 2 large plates on either side, followed by 2, narrower plates top and bottom. Because I created certain gaps where your HSS profile was rounded, or it created seams between the plates, you have your corners were kind of open. It didn't allow for that CJP weld to really have. There's some kind of a code provision. I'm not too clear on what it is exactly. It's in the AWS D1.1, so for whatever that means. I guess it's the American Welding Standards. And there's a code in there where the backer plate needs to be continuous or have only one, I think, butt joint or spliced in one location or less. I guess that'd be none at all. And so it gave us a problem. So since then, we are incorporating into our details anytime that we need to have some kind of a backer plate at a field or shop welded splice joint, that we would add a note, pretty much as per what I have right down here in this little green box here, that the shop or during the assembly stage on the assembly drawings, a continuous steel backer plate for CJP field splice as per AWS D1.1, and we would extend that 2 inches beyond end of HSS for field alignment. And so the idea behind that was that we would have the fabricators determine the proper size backer plate needed to meet the AWS standards. This comes with the assumption that the welders that they're being used in the shop are actually certified welders, and I pray that they are. And so they would have, better, more intimate knowledge of exactly the proper methods and procedures of applying this backer plate and doing the weld than, your run-of-the-mill detailer like us, where we have to memorize a whole bunch of other things. So we aren't necessarily expected to know everything. And so it's okay once in a while to just, have the fabricator make a certain determination as to how to proceed with certain connections. And this would be the case for the splice joint. So anytime there's a field or a shop splice joint with a CJP weld, we would add this note. And this is fairly recent, so Edward may be able to let you know a little bit more if you have any questions as to the why, or if you have any other concerns about it, but it was, again, very recent. I'm not sure if everyone's quite utilizing that detail yet or not, but we're trying to make this a standard going forward. If we're doing a mechanical connection, obviously this would no longer be applicable. The splice plate is actually a plate for a bolted connection, and so it would be determined by a certain thickness and a certain type of bolt connections that an engineer would let us know, what size plate to use, how it should be welded to like at least one side of the stringers, and so on. But for CJP welds, yeah, we're going to let the fabricators determine the shape and thickness to use, as long as it extends 2 inches beyond for that field alignment. Acts as a sleeve. Any connections any comments on this detail or what I just talked about?
No, I'm good.
Is this something that you guys have done in the past, or are there like maybe different ways that you've done this or approached a field splice?
Yes, we've typically positioned, most recently it was on the lower section of the Hank stairs in J, where we had large tubes that needed to be spliced in the field. And we made up a plate, I think it was 3/4 inch thick plate that was 16 inches into the tube. And we had 16 inches of material on the opposite side that would be fit in the field, that was all bolted. There was, I believe, eight holes on each side of the splice that we would fit the plate into position, remove the bolt, fill that weld for each side, and then ship that off to where the field could reassemble that in its exact position using the bolts again, and one by one fill those and then do their penetration weld.
Okay, so the bolted connection was more of a temporary means of assembling
exactly
the components together.
Yeah, for proper fit up, so
right,
that we could replicate in the field what we did in the shop.
Okay. Yeah, that I mean that could be. So I'm not. Yeah, if I'm not saying that it wouldn't work. It obviously did. Clearly, the cranky weld inspector that we had for Cloudflare was not the one that passed the welding on the job site that you were involved with. Yeah, it's possible that the weld inspector we had was just having an off day and kind of took it out on us. It's not something that we've had before happen to us. Generally, yeah, like the method that you've described, or even smaller plates, depending on the size of the assembly, smaller plates on 4 sides that would just be welded at one, and then we let the guys in the field kind of like assemble it and pull it together so that the joints are tight, and then they do their welds. That, I guess, we've done various methods before. We've never had issues, but for some reason, ever since that weld inspector came up there and gave us his opinion on things, we've had to kind of incorporate this detail now. It's not to say that this might not change later on. We might come to a situation where we think that this is not reasonable to do, and so we'll alter our standard on that. But for now, yeah, I think this will apply to most of our jobs. There may be exceptions here and there, but I think if that were to happen, we would be very closely working with the engineer and probably as well having someone certified in welding take a look at it, make sure that the design works and would pass the D 1.1 restrictions.
Yep.
Maybe one more thing to add to the splice joints, and I don't know if all shops do this. It kind of depends on the shop, but we've been asked recently, well, not recently, but I guess it's been expected for us to detail beveled edges. Whenever there's a CJP weld in field, we would model and show in the fabrication drawings and the assembly drawings that the HSS profile or channel or whatever stringer shape that we're using, if it was to receive a CJP weld, like a groove weld, we would actually show it and model it to be prepared with the bevel. So that when you show up on site, we're not expecting the welders to actually grind off a portion of the material to create that bevel so that they can do their CJP weld. So we may come across a situation, and if that happens, well, not if, but when that happens as well, if there's going to be a paint finish or a shot primer finish applied to the stringer, we would note in the assembly drawings that leave 2 inches of area all around the weld to not be painted, right? Not have a finish applied to it. So again, saves a little bit of time for the welder from having to grind off that finish, and they can have easy access to a weld directly to the steel. And then we'd have to come back, I guess, and touch up that area with, I don't know if it's spray on primer and paint or something else that they do. But that's something we have to also include into our drawings at some point. So the weld preparation, the beveled edges, and the notes not to add a finish, whether it's painted or primer, at about 2 inches away from the edge of the profile that will receive the weld.
Yeah, and that's both profiles.
Yeah. So when they're mated together, right at the joints, 2 inches to the one side and it's 2 inches on the other side. Yeah. All right. So that's it for splice joints. Yay. And the last one to talk about would be revisions and as-builts. So I guess the big item to consider on this is, while the field dimensions in a survey that we receive on site will play a key factor in how we design or how we do our drawings and therefore move on to our fabrication process. And unfortunately, most of our jobs, we don't get surveyed or field dimensions, whether it's by measuring tape or point cloud or any other system. We don't tend to get that at the start of a job. We tend to get that later on once we've already submitted initial submittal drawings to the client for their review. So you'll be probably expecting to have to modify your model and your drawings afterwards to suit those field conditions. It'd be nice if we can have it ahead of time. Unfortunately, with tight scheduling and all that, it's just not always a possibility. We wish for it. One job I'm working on, Snap, I was promised field dimensions at the beginning of January, and I was, mid-February, we still didn't have it. So, had to submit the drawings. So now I'm going to have to revise the drawings eventually when we get the field dimensions back. Fun times. And obviously the reason why we're revising it so that the stair fits on site. It's very uncommon for us to ever have a drawing from the architect match the exact site conditions. There'll always be something that gets thrown off a little. Your floor to floor heights may be off. It could be as little as 1/8 of an inch, and you'd be very fortunate if that's the case. And sometimes we're off inches. It could be an inch, it could be more. If the floor, maybe the initial survey that the architect did themselves when they did their drawings might have been off and threw everything design-wise out the window because of the floor to floor is bigger than what they expected. It could be sometimes an error when they're building the steel erectors, or the guys pouring the concrete, poured too much, or didn't pour enough, or didn't install the steel in the right spot. So floors can sometimes shift around from what was anticipated. But that's unfortunately going to happen, where we're going to have to revise our drawings. Other factors to consider, not just the floor of floors, but we have the opening size in the floor slab. So if our stair dies into the side of an opening, we need to know where that is, where that edge is. If there's steel support that we need to tie into, we obviously need to know where that structural steel is, so we can design our plates accordingly. Same applies with railings, really. We need to know where the floor openings are so that we can do our railings. We need to know where expected wall finishes are so that our railings, if it dies into a wall, we don't make our railings too short or too long. So yeah, we'll be working with field surveys at some stage during your drafting process, and it's will often be after you've done at least a preliminary set of submittal drawings. Have any of you worked with point clouds before?
No.
Okay. Do you know what the point cloud is?
Yeah, I've seen images and references towards it.
Right. Okay. Let's see if I can pull up a quick example, kind of give you an idea of what it looks like here. I'm sure you've seen it and you said it, but let's just kind of review it together while it's fresh in my mind. Da-da-da-da. That would be under miscellaneous.
Yeah.
Field dimensions. With point cloud drawing. Yeah, let's try this one here. And see if that crashes my system. I have so many drawings open right now, it's not funny. The little blue wheel of death. And a progress bar that's not progressing. Okay. Well, oop. Let's try recap. Oh, never mind. So this would be an example of a point cloud survey. We're probably going to be seeing that more and more as time goes on. And it's essentially, it's kind of like a laser scanner where it combines both those fancy measuring tapes that you can shoot a laser down something, it tells you what the distance is. It combines that with an angle finder and a camera. And it'll take a series of measurements, like dots, little dots, as this laser thing is spinning around and then moving left to right ever so slowly. And all these tiny little dots are going to be registered in 3D in the system, and it's going to be assigned a color based on the camera so that it knows, what the object looked like when it was captured. And then when you look at the point cloud, you can kind of make out a little bit better what it is that was scanned. So we're kind of fairly new at this in terms of using point clouds. I expect that we'll have to do a little bit of additional training to develop a standard of how we measure from one point to another. But it's a means for us to get a fairly complete survey done fairly quickly. And at the same time, eliminates the need that if we had sent someone there with a measuring tape and asked them to measure point to point, and maybe they forgot to measure something because they were busy with something else, or there was a long list. Either way, we didn't get all the information, or we're not clear what they measure to. We can always use these point clouds instead and figure out exactly where we want to measure, from a corner, from the bottom of the floor, top of the floor. We can pull all those dimensions ourselves if we wanted to. And I believe at some point it is also the intent that we can insert these point cloud drawings into our models, and then we can kind of ascertain where the floors are from what we've drawn with the point clouds, and see if there's a bust somewhere. Did we correctly factor in these field dimensions when we've modified our stair to suit? So it can help us find any errors that we may have unintentionally made while we were revising drawings or creating parts and all that. So for now, we haven't delved too deeply into point clouds, but we're just starting. So yeah, like I said, I'm sure working on a standard, and we'll be reviewing this, I think, in greater detail at a later time, how to incorporate point cloud information into our modeling. Otherwise, when it comes to as-built and revise and resubmit, or any kind of revisions that we do, there's a process where we send drawings to the client. It'll come back to us. They'll be marked up. Lots of red on there. It could be different colors. It could be very few comments. It could be a whole load of comments. Here's a nice example where it looks like someone bled all over it. And these are changes that I need to make now in my drawings. But it'll come back. There'll be markups, and so you have to go back to your drawings. You have to make the changes. And when you make changes, it's important that you cloud, within reason, what's been changed, and also add a triangle with a revision number that would be associated with the title block revision info that we will put in here. So in this case, this is the first submittal, so I obviously don't have anything in here that I've revised and clouded, but that will creep up at some time when you're working on these drawings, whether it's assembly drawings, application drawings, or erection drawings. If something were to change, if a dimension changes, or if the entire detail changes, then cloud, the entire detail, and add that little, add that little triangle thing here. That's would look a little bit like not that. Right, I'm sure you've seen that. You'll see that in architectural drawings. We repeat that the same thing as we would on architecturals. We do the same on our submittals. And that's a way to track what's been changed and make sure that everybody's on board that, oh yeah, okay, something's changed, this has changed, and we can backtrack with why was it changed? Well, was this a comment from the client or the GC or someone else? Knowing that it's changed at least gives us that start and figuring out like why was it done, and we can use that as a learning experience later on for future jobs. What can we expect that would need to be revised? But in most cases, it's just clients looking at these details and saying, you know what, I'm not really liking what I wanted originally done, and I understand that it was drawn that way, so I'm still going to make some changes. And it's going to happen. It's inevitable. Don't worry about it. Don't get mad or frustrated. It happens. It's all part of the process. What's important is that if it's going to cost more money, well, we'll get paid. So it's more money for us. Let's see what else. Oh, I want to bring up one last thing with as-built and revisions. Again, this is something fairly recent, and you might have seen that in Teams chat if you scrolled up in the past couple of weeks. Some PMs have brought up the issue where every time we would revise a set of drawings and send it out, not necessarily just to the client, but even internally for another set of review, some of us would be incrementally adding like revision numbers to it. So it would be a revision 1, even though it's we're not sending it to the client, we're just sending it to the PM for their review after they've already done some markups. Eventually that adds up to like a lot of revision numbers. And it wouldn't be uncommon to get up to like 10, 11, 12, and more in terms of revision. And it got a little much. So we're implementing a system now where we're only changing the revision number when we are submitting it to the client. And I guess if we're releasing for fabrication, if we're doing internal reviews, we are not going to change the revision number. It stays the same. So to give you an example, if I were to, so this would be the preliminary set of drawings. I send it to our team to review before they send it off to the GC. They have some markups, they bring it back to me, I make the changes. I do not change the revision number yet. I send it back to the PM, they look at it, they're okay. They had one thing they want me to change. I come back, I make that change, I send it back. I still don't change that revision number. And they'll send it to the client, and that stays as far as the client knows. We're really good at our jobs. We've only ever touched these drawings once, and they see it as, revision 0. It comes back to us marked up, red all over, kind of like this. And I make these revisions and I'll send it to the PM and he'll take a quick look, he or she will take a quick look at it. And if they think that there's something else that they want changed, they'll bring it back to me. I'll make that change. But that would only, those series of changes would become revision 1 because we've received the drawings back from the client. And so any changes afterwards is automatically revision 1. But stays at 1 until we send it back to the client for reapproval if it's needed, or if we're releasing it for fabrication. So that's hopefully going to limit the number of times that we're going to be kind of like changing the revision numbers. I'm going to have that kind of described a little bit here in the sheet I'm going to forward to you. Oops, I could stop scrolling up. And hopefully that kind of explains it well. If not, you can ask me, or feel free also to ask Edward. Again, this is something that's fairly recent, so we're maybe not all quite, how do I say it? We're not quite at ease with implementing this change just yet. Some of us may still kind of like be struggling with, okay, when's the right time to change the number or not? But yeah, feel free to reach out to myself or Edward, and we'll try and clarify what exactly we mean by when you should change a revision number on your title blocks, whether it's again submittal drawings or fabrication drawings or assembly drawings. And at the end of a project, you should have a set of as-builts that is essentially your submittal drawings with the mark numbers for all the parts or assemblies. They'll be included in your drawings. They'll be revised to the site conditions. They'll have all the changes that the engineer wanted, and hopefully the engineer will be able to stamp that as well. In terms of submittals, that should be it for as-builts, and your fabrication and assembly drawings should be up to date. And what I mean by that is it's not just what you've done or what you've initially drawn while you were in the office, but if there's any changes done on site after the part was fabricated and shipped to site, and they figure out, oh, this doesn't fit well, it should have been done this way, so we made that modification, we cut this angle a little shorter, we moved the hole there. That information should ideally trickle back to you at some point, and you can make the revisions to your fab drawings, your part drawings, your assembly drawings, whatever, any drawings affected by those changes, so that 10, 20 years from now, if the part gets damaged or if they need to replace it, they'll know exactly how to reproduce it, because it'll be drawn to the actual on-site structure that's there. It doesn't always happen. We don't always get that trickle-down information from the site supervisor, but I believe we are also struggling or are striving, I should say, to try and get that information to us in a timely manner so that we can incorporate those in our drawings. And that's it really for revisions and as-builts. I don't know if do you guys have any questions, comments,
Nope.
complaints, jokes?
Nope.
No?
Knock, knock.
Yeah. Who dare? All right. Well, I mean, that's good. We're still, and you're going to see this in chat. We're still kind of refining some of our standards in Synergy, whether it's what I talked about or maybe what Dan's talked about. As we're implementing our software, Advanced Steel, with new technologies like point cloud systems and new situations on a job site with engineers that we're working on, things are going to change. So everything I've said today is not necessarily going to be printed in concrete kind of thing, like it's stamped in there and it's going to be permanent forever. It might change. It could change in next week. Who knows? But when it does, just keep that in mind.
It's fluid.
It'll be very fluid. We've definitely changed a few things, I'd say, in the last few months. Not a lot, but we've changed a few things. And we've had, I believe, were you in attendance yesterday with the building code seminar that we had?
Yeah.
Yes.
Okay. So, we kind of a refresher course for a lot of us, maybe a learning experience for others who didn't know it. But, it's good to kind of retrace our steps and get back to basics and figure out, okay, well, what's code requirements, what's engineering requirements that we need, and things of that nature. So we will do little seminars like that to try and give you a refresher. And sometimes that kind of does a bit of a course correction in our standards and our how-to processes of drafting and doing our jobs for the company. So again, what I say is not necessarily set in stone, but if there's any questions that you have or any concerns or if you have feedback or you want to talk about it, feel free to reach out to myself, Edward, or anyone else on the team. We are here to help each other out. And, we want to make sure that you can do the best job you can. And to do that, we need to be able to give you the answers that you need. So, don't hesitate to ask. Just if there's any questions on this or you're not sure if it's the right way, just let's have a chat about it. I'm not going to turn you guys away for that. I'm not going to get upset or angry or anything like that. Again, it's all just for the betterment of the company.
Yeah.
So I think with that, I'll conclude this little, and by little, it's a 2-hour long session here.